This is Team 3's heat exchanger made by Lauren Jacob, Alex Carson, and Kaiwen Zhang. Our design is a plate heat exchanger. Since our team is going to be vying for figure of merit number 3, we wanted to lower the mass of our heat exchanger. The sides of the heat exchanger were insulated with quarter-inch polyethylene sheets to reduce the heat loss to the surroundings. Heat is transferred between 12-inch by 4-inch by 0.02-inch aluminum sheets. Quarter-inch thick acrylic gaskets carry the water between layers while forming the snaked flow path within the section. 12 3-inch quarter 20 bolts were used to hold the layers together in addition to RTV sealant. The inflow and outflow tubing are 1.5 inches long and are made of 1/2-inch outer diameter stainless steel pipe. We used a shear and drill press to manufacture the aluminum sheets, and gaskets were cut on the laser cutter. Here is a diagram of how the hot and cold water flow within the heat exchanger. The hot and cold water inflows are on opposite sides from each other. Water flows diagonally up or down within each layer. The gaskets direct the flow and allow the other temperature water to pass through that layer. Since the first evaluation, we changed the number of bolts from 10 to 12 to add extra support around where the water would flow through. We also changed the shape of the water flow path to increase its surface area. For the first evaluation, we did have leakage within the layers that caused the mixing of hot and cold water. We learned to not use flexible tubing and to apply sealant around the corners between the aluminum sheets and the gaskets to minimize this leakage. For our final model, we used the same design, but used 5 aluminum plates instead of 3, and we let the sealant between each layer cure before sealing further layers to prevent leakage. In our final evaluation, we also oriented our heat exchanger vertically so that each layer could completely fill with water. The hot water inflow rate was 3 liters per minute, and the cold water inflow rate was 2 liters per minute. The hot water in temperature was 41.2 degrees Celsius, and the cold water in temperature was 18.5 degrees Celsius. The hot water out temperature was 33.4 degrees Celsius, and the cold water out temperature was 30.9 degrees Celsius. When running the test, there was no leakage in the heat exchanger except the small leakage at one of the connection points. The decrease in hot water temperature is smaller in the second evaluation than the first evaluation because the cold water and hot water were mixed between layers in the first. The one thing that did not work as expected is the heater did not heat the water up to the required test temperature of 55 degrees Celsius. Our advice to future students is to create a prototype before the first evaluation. We believed that we did not need to create a prototype before building our first iteration, but looking back, we realized that this would have significantly increased the results of our first evaluation.